My name is Piotr, and I'm going to be talking about building and scaling an AI startup using async Django. The idea of the talk is to move fast and don't break things. So whilst I'm going to be talking about RAG as an example of an AI application, this talk itself is not about RAG. It's about more of an engineering talk. It's the fact that AI changes extremely quickly, probably every 3 months. So you have to be able to build applications in such a way that you can iterate quickly, swap out components, refactor, and scale for market fit. So as an example of an AI application, I'm going to write a specification. So the specification is that we want to be able to upload PDFs and text documents and ask a large language model for queries regarding them. We want to be able to support confidential documents, such as medical documents, financial documents, that kind of stuff. So our MVP should be designed in such a way that we can refactor it to be able to self-host our large language model and anything in the infrastructure. So large language models have a memory limit, specifically something called a limit in the context window. A context window is the amount of tokens that a large language model can operate on. So large language models themselves don't directly operate on text, they operate on something called tokens. A token is a way of sort of compressing text so you can fit more of it into a context window. I'm not going to talk about it, as it's beyond the scope of this talk, but there's a fantastic talk about it by Andre Karpathy. I highly recommend that talk. What I want you simply to understand is that a token is approximately half a word or maybe an entire word. GPT-4 is between 4 to 32,000 tokens. Cloud AI claims up to 2,000 tokens. So the token limits keep increasing, but they still have a limit. You still can't upload an entire collection of ebooks and into a context window and expect a large language model to provide you with information. So the current hack around this memory limit is to use something called RAG, so retrieval augmented generation. What you do is you take your documents, you cut them up into small chunks. You then take an embedding model. An embedding model is like the earlier layers in a large language model which are able to extract semantic meaning, i.e. approximately understand the meaning of a bit of text and represent it into a vector. Those vectors get stored into a vector database. Then later, when a user asks a question, that question is also embedded and converted to a vector. That vector is then compared to other vectors in the vector database, and hopefully you retrieve chunks of text from your original documents which have relevance to the user question. You then pass in a prompt to your large language model with the retrieved chunks of information for the vector database and rely on the large language model to give you something interesting and sane out of it. So what exactly do we need for an MVP? I mean, if I'm going to demo to clients or let the product managers go out and talk to clients, what exactly is particularly useful to have? So being able to log in and log out. Technically, it's not a hard requirement, but it's insanely useful. If your product manager is trying to sell to different clients or demo, having each client have its own user space, have its own area where they've uploaded things, it's really, really useful, and Django provides that out of the box. Having automatic generation of API documentation and open API specifications is also extremely useful, especially when you start to scale and start to develop code in JavaScript for the front end. And again, this comes out of the box with Fast API, and Django also with Django REST framework and Django Ninja. Being able to stream replies in real time from large language models. Large language models essentially predict the next token, so the next bit of text. So the way they operate is you submit a bunch of text, it predicts the next token, and then you resubmit it. So you get an output from it, one token, one word at a time. And it's really immersion breaking if you wait for the entire response, because that could take 30 seconds, and it's super nice if you get each token coming out, and the user can see it. And finally, you need some kind of UI so a user can upload files, they can type things into a chat box, and get some kind of meaningful response. So I want to talk about Python as an AI ecosystem. You can build a backend in multiple different languages, Ruby on Rails, JavaScript, Java, but it significantly simplifies things cognitively if you can standardize things on Python, especially as you scale a team. As your code base gets bigger, more mature, and hopefully well written, you can often onboard less experienced developers, let's say JavaScript developers who may be touching part of the Python code base. If your code base is fairly mature, well structured, and tested, they can see how things are written and build things on top of that. It may also be the engineers who work with the data pipelines. They may be able to take a look into your backend code. If it's all Python and it's all written in a sane manner, it significantly reduces the cognitive overhead. The other thing I really like about Python is Pydantic. It's a superpower. So Pydantic I use in two places. One is when writing the APIs, so for your front-end client, as it allows for easy schema generation, especially into TypeScript. The second is for the data pipelines. Data pipelines usually accept binary encoded JSON, and so you're throwing JSON all around, one microservice to another to another. And it's super easy to make mistakes here in terms of validation. Validation by hand is tedious, tricky, and insane. It's super easy to be able to just write a simple Pydantic schema and then just have it serialize, deserialize, and validate. So initially, when I started experimenting with an MVP hack, I started with Fast API. It provides a Swagger API. It provided the streaming responses. But I got frustrated with it because at some point, I had to add in user models, authentication, access to the database. So I switched to Django because I have a lot of experience with that. So Django comes out with all these things out of the box. And it's fantastic for quickly writing business logic. Django isn't suitable for everything. If your application never has to touch a database, Django is overkill. If your application never has to deal with user models, don't use Django. But it is great for building out business logic very, very quickly. A caveat for it, though, is it does have a learning curve. I've been working with Django for about 7 years now. I worked 3 years with one company with Django, and I thought I was pretty good at it until I switched companies and then came across even more experienced engineers. And yeah, it does have a learning curve. If you're getting started with Django for the first time on a commercial project, it really pays to have somebody else with experience in Django, even if you're just getting into code reviews. The other really thing I like about Django is that it's security reviewed and audited. 2 scoops of Django is also audited from a security perspective, which apparently is why it takes such a while between releases. When the company I worked for had a security audit, it helped us a lot because we used Django, and we didn't just YOLO our own authentication. So for an initial hack architecture, you basically offload everything onto the Django workers and rely on the fact that you can get it to operate in an asynchronous manner for any long-running operations. Specifically, the trick you can do with async Django is that they provide a decorator called sync to async, where you can wrap a long-running blocking process and have it run as a separate coroutine. You have to be a little bit careful with this, as there's 2 ways of running it. One is with thread sensitive false, and one is with thread sensitive true. By default, sync to async runs with thread-sensitive true because it takes a very cautious approach. Django itself doesn't actually use threads, but certain things such as connection to the database does. So you can take certain parts, such as, let's say you've uploaded a PDF, text needs to be extracted from it. That you can run on your Django worker using a sync to async with thread-sensitive false. And you can basically cheat without having to build out complicated data pipelines while you're building your MVP. The really other nice thing about Django is that they introduced streaming responses in Django 4.2. So specifically, you can call your large language model, which is hosted somewhere on a GPU, get it to provide a response in terms of an iterator, and then reproxy it back to the user in real time. This is a feature of Django 4.2, and we can make use of the fact that by proxying via Django directly, use its authentication so we don't have to build anything super complicated on top. Again, we can also cheat it a little bit by using Django's templated views. So Django is pretty old. It was always designed with the idea that you should be able to render HTML on the back end to the front end using a templated language. It's an older approach, but it makes up for it in its simplicity. Turns out GPT-4 is actually really good at generating HTML, probably because it's trained on a lot of it. So if you're mostly a back-end developer like myself, you can get ChatGPT to generate a lot of the raw HTML templates with tailweight CSS, or you can pay for a pre-built template. And then for the functionality such as some of the JavaScript, you can just write that yourself, keep it simple. I played around with HTMX, but I thought I struggled a little bit with it, and I found it easy to just write simple HTML. This will get you pretty far with just a simple UI, but you will struggle when you want to do more complicated things. Firstly, if your UI needs something more complicated, you can't really write unit tests with JavaScript without Webpack. Webpack is a beast. Once you get Webpack in, you may as well go to something like React.js. And there are certain things that a simple templated UI can't handle, such as, for example, I upload a PDF and at the same time ask a question. The UI will basically refresh at some point by reloading from the server once the file upload is completed, and it just breaks the UI a bit. It's fine for an MVP, but it's not. There's only so much you can do in terms of just templated UI. The other thing I wanted to point out is to use AI as much as possible in writing these things. I know some people consider this controversial, that, I don't know, AI is cheating. But there's a lot of expectations of us as developers. We're expected to do everything, front end, back end, DevOps, and now ML, and to do it in polynomial time. So the AI helps a lot with that. I found that GPT-4 works very well if you call it via the API. Don't use the web client or the paid version of ChatGPT because they've lobotomized it. It got considerably worse and worse over the past sort of 6 months, and it's actually really interesting to see the answers you get via calling GPT-4 via an API and a third-party interface, such as BetterGPT, versus actually using the web UI. One of the really cool things with using the UIs is that tests are so much faster to write. That you can take, if you're writing your code in a simpler way, simple functions, simple classes, you can paste those into GPT-4 and get it to suggest tests, copy and paste them back in, see what breaks, and just iterate very quickly. It was also super useful with doing things like tricky mocks. Mocking can be a little bit fiddly to get the right sort of part of the patch in Python. Or like getting tests working for the Django admin interface is a bit tricky, and AI was super useful. Again, I want to reiterate how important tests are when building your MVP, because they help you move quickly. You can maybe code for 6 hours a day when you're fresh. If you're coding beyond that, you're starting to regress and make mistakes. Tests prevent that. It also helps you scale a team because people can onboard much, much quicker. They can see how the code is supposed to work. Tests are living documentation, and they help you move much, much quicker. So I've talked most of what's on this slide. The other thing is that when you're starting up a project, start up CI. So GitLab and GitHub both have CI out of the CI that's fairly easy to integrate. I personally prefer GitLab. If you're writing unit tests, CI will catch it, catch any failures, and prevent regressions. The other thing that I found extremely useful was adding in log shipping, error reporting at the start of a project such as Sentry. So when people were experimenting with my MVP hack, obviously I'd written tests, but there were things I'd missed. Sentry would just report errors as users basically found edge cases, and I could easily fix, test, and patch the results. Okay, so there was an extra speaker slot with this conference, so I'm actually giving a part 2 to this talk at 2 p.m. So that part 2 will be about actually scaling the MVP hack, and in terms of what I've built, what breaks when you start to throw users at it. So that part 2 is at 2 p.m. I'm going to start off, because I'm starting to run towards the end of the talk. I want to thank you for coming. There will be a part 2 at 2 p.m. I want to say that if any of you are in Warsaw, come visit. It's an amazing city. I'm involved in 2 projects out there. So one is a meetup called AI Code and Coffee. The idea is just in the name. You bring your laptop, buy a coffee, and we work through AI papers, or discuss anything that's AI relevant. It helps us basically keep up with things as they're changing. As a second project, and there's a conference in Poland called MLMPL that runs once a year. It's a really good conference. They mostly have a university background, so there's a lot of high-end technical talks. When you go to conferences, a lot of the AI conferences aren't really AI. They're more, let's plug into ChatGPT or host a model. This conference is really, really good as they have a lot of AI researchers on the edge of AI research. And finally, I want to thank the organizers of PyCon Lithuania. It's a lot of work to sort of organize a conference, and I want to thank them for organizing the conference and inviting me. So, questions? It's 20 minutes, right?
Yeah. Yeah, you're 2 minutes early, so you still have time, and we have time for questions as well. Yeah, do you have any questions, guys? Yeah, go ahead, Maxim.
You say never use Django if you not bind it with databases.
Mm-hmm.
Why?
So Django, by its internal design, assumes you're using a database. So that it ties in very tight with the Django ORM. It ties in also very tight with the idea of having a user and the authentication base of all of those. I think it's just a lot of, if you're not connecting to a database, the ORM doesn't really make sense. The authentication isn't really useful because you're authenticating via a user. At that point, you may as well just use Fast API.
Why?
Because it's a lot simpler. Fast API is a lot simpler than Django. I mean, I'm open to suggestions. Like, Django does have a learning curve.
Difference of opinions, I see. Okay, any other questions? Yeah, please.
Could you advise your favorite UI for ChatGPT, for GPT-4?
I use Better GPT. You can just go into their website, type in Better GPT. Of course, you've got to paste in your API key. So obviously what I do is I go into GitHub, clone it, and run it locally. And it does produce significantly better answers than using GPT-4 via OpenAI's interface, which is, it's surprising. Sometimes it's also, it's not just the length of the answers, sometimes it's actually the quality as well. GPT-4 sometimes gives very good answers for weird things such as performing complex SQL queries via the Django ORM. The Django ORM is a wrapper around SQL. Sometimes you want to do specific queries, annotate things, and it will give you answers which are extremely, it saves a lot of cognitive overhead.
Yeah, question there.
So you mean that you basically want to run everything without a network access, right? Okay, so the idea behind this is that you should be able to run everything locally, i.e. your own servers. So you pick a large language model such as Llama 2, you self-host it using VLLM. VLLM is an inference engine which has a bunch of optimizations, batch processing, and it's just faster than running it via PyTorch. You need, I think, about 160 gigabytes of VRAM to be able to run Llama 2. So that's 2 H100 GPUs, or use a quantized version. So you need a machine that you can physically run a GPU on, and your large language model, and your Django instance on a separate machine.
Okay, any last questions?
Essentially, also, you can self-host yourself, so everything you can self-host without external network access. You still, of course, have to download the initial Docker images, that kind of information, but you can then block all outbound and inbound.
Any last questions before we go to the lunch? Thank you so much, Piotr. I'm leaving you with a final point that I would like to ask you as well. Recently, PyCon Combinator launched the latest batch, which is one of the biggest ones in the accelerators and startups and so on. It's around 150 startups there. Mm-hmm. And mainly, many of those are AI startups. Mm-hmm. What do you think, where we will go next from there?
So startups are weird. Like, I went to a hackathon about 2 weeks ago in Poland, and I went to a hackathon 15 years ago when I started getting into software. And the problem with startups is that all the low-hanging fruit is gone. 15 years ago when I went to a hackathon, and we could build a startup using a small team of developers. Now, if you want to build a startup, you need 10, 100 million to actually make an impact. You're competing with basically people who need money, who basically have money to train on GPUs, and it's a very different game now. You actually need a lot of money. It's also, like, you see that there's a lot of consolidation now, that there's a few big key players when it comes to AI, because there's the French company Mistral, I think. There's obviously OpenAI / Microsoft. There's Cloud AI. There's maybe one or two other smaller players. But the money is eye-watering. It also plays into the economics of the Silicon Valley CEOs. So GPT-4 was estimated to cost about 100 million to train. And the way they think is that it takes about a factor of 10 in terms of scale to reach the next level of AI. So when they're thinking we're training 100 million for GPT-4, the next one is going to be 10 times bigger than that. And the next one is bigger than that. This is why they throw $1 billion towards building a new data center. And 100 million is a lot of money for us, but a big tech company, it's not that big. So it's $1 billion, 10 billion.
Yeah, significant decision, but it can be manageable.
It gives them a massive advantage, and they realize these things, the emergent properties seem to scale with size.
Yeah. Thank you so much. Thank you so much, Piotr, and applause to our speaker today.